All right, so here's my little web audio API program that transfers data over audio. And some of the changes right now are that I'm actually showing the actual decoded value of the text that I actually sent over the airwaves, I guess. um, they are the airwaves. They aren't over the airwave. Well, I'm just trying to think how you can actually explain what's going on here. Um, yeah, so what's new here is you see this encoded box and a decoded box, and you see a lot of red bits flagged here. And what that entails is error code correction. So I implemented the Hamming code error correction so that once I receive a signal over here, I have a chance to repair the signal if I can identify bits that are flipped the wrong way. And there was enough parity bits here that my decoded message actually matches exactly what I sent. Don't worry about the last character here. That is something sort of related but unrelated. That has to do with I'm sending a 10-bit number at the beginning of my packet, and that 2-bit offset causes a problem with Hamming code error correction because it expects 4 bits instead of 2 bits at the end of my packet, if that makes sense. Yeah, so I can keep typing away. All right, and this time we had no errors. And that's the other thing is I found some frequencies that actually work out pretty good for me, even at a very short duration. So before I could only get this duration down here down to 40 milliseconds before I start getting into problems. Right now I'm getting it down to 10. I think if I get it down to 9, I start having problems. Yeah, there's too many problems here, and it couldn't recover a lot of stuff that came through. So 10 milliseconds seems to be the sweet spot for this frequency range. Part of that is the FFT size has to be to the power of 7. This FFT size affects how quickly the amplitude falls off with the analyzer, and then that also affects how wide a frequency band is, or a frequency resolution is for each band that the analyzer looks at. And then I do my own thing where I try and multiply that frequency band by 1, 2, or 3. I'll multiply the resolution and choose every third frequency to create a new channel, or one part of the channel. So a channel has 2 frequencies. So we have a low and a high. The frequency resolution right now is 375, and I'll multiply that by 3. So we're getting up to like probably like 1100. So 3995 plus 1100, yeah, it is close to 5120. It's not exactly 5327, but it was the closest I could kind of get the values to pull from. All right, and then the other thing is I'm actually calculating like lots of the effective speed, the effective baud rate, just so I can gauge, am I close to the old Atari 410? Am I getting there? The baud of the 410 was 600, and it just used those two frequencies. um, but it was evaluating them at like 0.6 milliseconds, and I can't evaluate frequencies any quicker than 3 milliseconds with the interval timer. For some reason, the interval doesn't call any quicker than 3 milliseconds, and I'm not even guaranteed that. So there's things I need to do to catch up to the old technology. um, let's see, frequency resolution, samples per size, bits per segment, total bits. Yeah, all this packet stuff is new. So a lot of this is just writing out information I'm usually debugging, and I don't want to keep console logging everything. Just throw it on the page, and I can see it clearly, and I can take snapshots of like what my configuration was or what the information was. That's pretty helpful. Yeah, other than that, I think we're pretty good.